talk about that zero point 0.9 repeating equals 1. And I think you offer 3 different proofs for this. But I thought and what I want to be clear is that zero point 0.9 repeating is not close to 1, not infinitely close to 1. It is 1. Can you expound on that, Jake?
Yeah, I mean, I think I said somewhere in the book that this is right, that many students, whether this was presented in in middle school, which I think is the first time I saw it, with no justification, right? When we were doing repeating decimals, right? Or whether you see it in high school where you start to get a little bit more justification, or certainly in calculus when you can have sort of a full formalized proof of it. What I think I said in the book is many a student has argued with their teacher about this, right? And saying, look, it's really, really close to 1. I get that. Or even going so far as to saying, it's as close as you want to 1, but it's not 1. And it turns out, actually, it's true. Now, it is equal to 1. Now, what's kind of interesting about this, though, is almost nobody argues with 0.3 repeating being 1/3.
Yes.
It's like that decimal is so familiar to us, we've accepted that. I think that both those facts deserve to be accepted with proof, but also deserve to be challenged until there's a proof. And I say that just to note that I do think it's interesting that people have no trouble accepting 0.3 repeating being 1/3, but have a ton of problems accepting that 0.9 is 1.
Well, correct me if I'm wrong, but isn't the fact that the 0.3 repeating, maybe I'm using circular logic, but for me, I have an easier time accepting that. I've come around to the 0.9, don't get me wrong, but I have an easier time accepting that because 0.3 repeating can actually be written better as a fraction, whereas there's not really a better way to write 0.9 repeating as a fraction.
Yeah, it depends on how elegant you think the fraction 1/1 is. That's a pretty elegant fraction to me. So I think the reason why people accept the 1/3 as 0.3 repeating, though, is because they know how to take 1/3 and do it as a division problem, and they'll see the 3's coming up over and over and over again. In other words, and maybe that's what you're getting at, the proof for 1/3 and 0.3 repeating doesn't have to go from 0.3 repeating to 1/3. It can go the other way around. You can start with 1/3, do the division, and see the 3's keep coming up. You can't do that with 1/1, to your point, maybe, right? If I just divide 1/1, it's not like I'm just going to start getting a bunch of 9's. You have to be really clever in how you're doing that. But I do bring up 0.3 repeating, not only because it's accepted, but because that at least offers a less formal proof, but at least the idea is the broad strokes of a proof for why 0.9 repeating would be 1. I mean, after all, if you take 0.3 repeating and you multiply all the digits by 3, you get 0.9 repeating. So 0.3 repeating times 3 is 0.9 repeating, but 1/3 times 3 is 1. And that's a pretty intuitive proof. Again, if you know some calculus, for the mathematicians listening, there are certainly some issues that need to be dealt with in that. But I think for most people, that's a pretty intuitive proof for why 0.9 repeating has to be 1. The other intuitive proof, and I think actually most of my high school students bought this, is, look, there's a property of numbers that says if they're not equal, one of them has to be less than the other, right?
This is my favorite one. This is my favorite.
Yeah.
I like it.
And it does seem clear to me that it's clear to everybody that 0.9 repeat is not bigger than 1, right? So it's either less than 1 or it's equal to 1. And the beautiful thing about any two real numbers is if one's less than the other, there has to be a number in between, always. And I know that because I can average the two. That's not the only number in between, but the average of two numbers that are not equal is always between the two numbers. And so if we think 0.9 repeating is not equal to 1, we are obliged to find a number in between. And you can't do it. No matter how hard you try to construct that decimal, you can never find something that's in between. And if that's true, you have to then admit the only other possibility, which is that the two have to be equal.